Okay, we're going to continue combining rational expressions, which is what we did in our last example in our last video. And this one is a little bit harder. So again, this should be reviewed, so there aren't a ton of these slides or examples, but let me get started. So it follows all the normal rules of regular fractions. We need to have a common denominator. Well, when we look at these polynomials, we have no idea if we have a common denominator or how to get one. What we need to do is factor. So now I don't like it written like this. I would, hold on, let me talk you through it. So I would write it like this. This first one has the square roots on the front and the back, and the middle is double, if you know what I'm saying here. This is what I mean. So it's a perfect square trinomial. Square roots on the front and the back, the middle is double. It's 2x twice, which made the 4x. So I've factored that. Now I'm going to do the same, factor this one down. That's x minus 2, x plus 2. Now we need these denominators to match. But now that they're factors, it's very easy to do. If you look at this, this has 2x plus 2s. Those are two numbers, x minus 2, x plus 2. These are two numbers. I need them all to have the same number. So what this side needs is an x minus 2. But if you give it to the bottom, you got to give it to the top. What this side needs is another x plus 2. It has one, but it doesn't have them both. So I'm going to give it another x plus 2. But if I give it to the bottom, I have to give it to the top. Okay, so I'm going to multiply this through. I get 6x minus 12 on the top there. I'm going to leave this as a negative for just a minute. 2x plus 4 over here. Now, those denominators are a match. Now, I'm just going to ditto that over here. I don't want to write all that again. Now, the only other thing you got to be careful of is I have a subtraction sign. So that is going to turn, so the denominators now match. This is a negative. With a polynomial, you got to watch out. What that means is I'm going to be doing 6x minus 12 minus 2x and minus 4. Does that make sense? So the denominators match, so that's just going to come over and be the denominator. Again, I'm just going to write that because it's all three of these. It just keeps coming over. So if you have fractions that have the same denominator, you can just subtract the top, leave the denominator the same. You just have to watch out for that minus. It becomes minus 2x and minus 4. Okay, so I combine like terms. I get 4x minus 16. And then I was checking to see, yeah, it doesn't. Okay, so I factored both the bottoms. I made sure then that everybody had the same numbers on the bottom. If I had to give one to one side, I gave it to the top as well. Now I multiplied, I cleaned up on the top, just multiplied through. Then if you have fractions, 3/4 minus 1/4, you can just subtract the top and keep the bottom the same. I'm doing the same thing here. So the bottom is all this craziness, it's just going to be the same. And then I subtracted these and I got 4x minus 16. Now, you'd have to check. Make sure that you couldn't factor this and then have it cancel something on the bottom. And the top does factor, but I looked ahead and saw that's not going to cancel with anything on the bottom. So this would be okay, but you have to double check to make sure this can't be factored again, and perhaps you could simplify something further. Okay, try it on your own if you want to. I'm going to go ahead and start. Okay, if you're following this idea, this is a number x plus 5. It needs the number x minus 3 put over here too. But if I give it to the bottom, I've got to give it to the top. This one has the x minus 3. He needs the x plus 5. If I give it to the bottom, I've got to give that to the top. Now let's send this through. I get 3x minus 9 over here. Over here I get x plus 5. Now I'm just going to put, well, I don't know if I should do that, but all of this is over this fraction now. I just don't want you to miss. This was subtract, so I shouldn't have done this because this negative is going to go to both of them. So I have 3x minus 9 minus x minus 5. Negative x, negative 5. Now all of that's over x plus 5. Oops, x minus 3. Now clean this up. We've got 3x minus x is 2x. Negative 9 minus 5 is negative 14. Now once again I would check this. You have a GCF here of 2. But if I pull that out, I'm going to be left with 2 times x minus 7, and it won't cancel. So that's okay, but just make sure that it doesn't simplify further. Okay, now these are called complex rational expressions. It's just, well, I don't want to give like a whole long story on this, but all you do is check to see if you could just do the problem on the top. Just combine those. And then check to see if there's a problem in the bottom in the denominator that can be done. In this case, there's nothing to combine. And then the third problem is the whole thing where I have a fraction being divided by a fraction. That's going to be keep, change, flip. It's really the same as if they were written with a division sign. A fraction bar and a division are the same. So let me tidy up this on top first. Now how do I do that? Well, I'm going to make it y over 1. Now, these need a common denominator, so he needs the x. If I give him to the bottom, I've got to give him to the top. Now, you could think of, does he need the 1? Well, we could, but that doesn't do anything. So really, these denominators now match. I can add the top, keep the bottom the same. So that's what the top turns into. So I've got y, x plus 1, all over x. Now, secondly, if I had to do all this again, I would. If there was a whole other problem on the bottom, I would do that and then put it down below. But there's nothing else to do. It's already done. So now we're to the third part. Keep the top, change it to multiplication, and flip it upside down. Flip the second one upside down. Okay. This is a very strange one. Normally when you do this, things would cancel out, and nothing does here. So let me see how they wrote this. Did they even bother to? So this is where we were. Usually things will then like cancel, simplify down, but they don't here. Again, I don't usually see them like this, but what you would do is top times top, bottom times bottom, which is how they got down to that. Okay, so we've got a problem on the top, a problem on the bottom, and then we're going to keep, change, flip as our third one. Now the bottom is done, so all we've got to worry about here is the top. Now they need to have the same denominator, so I'm going to give him an x. I give it to the bottom, I've got to give it to the top. He needs a y. If I give it to the bottom, I've got to give it to the top. Now, what is this? I've got x squared minus y squared. It doesn't matter. These are the same denominator. It doesn't matter the order you multiply. So over xy. Okay, that's the top. I've simplified it. Now usually you'll have one on the bottom you have to do too, but there's nothing to do here. So I have this being divided by y. We'll keep, change, and flip the y upside down. Now again, this is pretty atypical. This isn't usually what you see here, but we would multiply the top times the top. You get x squared minus y squared because it's just times 1. On the bottom, you'd add xy times y. That's going to be xy squared. Okay, now again, those are hard topics, but I'm assuming that you've seen those in Algebra 1, and this is just a quick refresher. I keep saying this, but I've got the old Algebra 1 videos if you want to take a look at those.